Hello everyone. In this session, I want to talk about construction of different kinds of portfolios and how do I really evaluate the effectiveness of the portfolio. For this, the entire discussion along with the conceptual aspects, we would be using R for constructing the portfolios as well as evaluating them. And within R, there are so many packages that are available with respect to portfolios, but I would be focusing on one package which has lots and lots of features as far as the portfolios are concerned. It can help us in creating different kinds of portfolios with different parameters, right? We can change so many attributes of the portfolio, and even evaluation wise it gives me wide variety of opportunities to evaluate the portfolio. So that is the reason I would be using the fPortfolio package primarily for this whole activity. And practically I would be taking you through creating a portfolio on a data set, right? We'll talk about different kinds of portfolios by changing the different specifications for a portfolio, and on that various portfolios that we have created, we will do the evaluation. So the data set that I would be taking for this purpose is a monthly index values of different sectors of around 11 sectors on the Bombay Stock Exchange. Their monthly index values collected from January 2007 till December 2016. So this is the data set that I would be using for building the portfolio and then creating the various computations or the various calculations with respect to the risk of that portfolio, the value at risk on that particular portfolio, and various other measures as well as the risk budgeting as well. So going into the agenda for this session, we will talk about the various specifications of the portfolio. So how a portfolio is helping me in terms of building a portfolio, what all kinds of specifications I can give as a part of my portfolio specification. We'll try to understand this one single function which helps us to set so many things regarding a portfolio. So what all settings I can do for creating different kinds of portfolios, and whatever the results that I have got, how do I really evaluate the various, how do I really retrieve the various results? Let's say the portfolio, I have run the portfolio and it has given me the weights associated with the different weights associated with the different sectors. Now, how do I retrieve the weights? Or how do I retrieve the return that the portfolio has generated? So these kind of things, if I have to retrieve some kind of a data, what are all the different kinds of functions that I can use? Then I'm talking about different kinds of portfolio constructions based on the different objectives that we are carrying. Sometimes we may say, I want the portfolio to be very efficient. Sometimes I want a minimum risk kind of a portfolio. Or sometimes once I specify a return or specify a risk, for that particular risk I want the portfolio that is giving me the maximum return. So I may have different kinds of objectives with respect to what is effective for me. So I want to retrieve those kind of portfolios. I want to create them. And once a portfolio is created, we actually have some kind of computations on the portfolio, like what is the value at risk for that particular portfolio, what is the expected shortfall for that portfolio, some kind of risk related computations associated with a portfolio. And we would also look at efficient portfolio frontier, making sure that what portfolios are efficient and what portfolios are inefficient based on the risk and the return profile of the various sets of investors. And finally, we would also spend some time in terms of understanding the risk budgeting, which is nothing but how do I allocate the risk across the various constituents. In this case, I'm talking about 11 sectors. How do I allocate the overall risk across the various sectors based on the proportion of based on the weights that are given to each of the sectors. So these are all the different kinds of topics that I am going to take up. So which means once you actually get into the process of creating a portfolio for your kind of data, almost all these mechanisms would definitely be handy for you. So let's get started. Though there is much more as a part of portfolio construction and analytics, I can very well say this session will have lots of input for you to build your own portfolio, to evaluate your portfolio at regular intervals of time. So getting started, first let me get the data, right? So this is the data which is present in my this particular folder, BSc index.csv. I'm reading it into R, doing a initial preliminary checks. I'm looking at the head. It is telling me that I have monthly data and the data, the index values relating to these few sectors. So that is what is my input out here, right? And if I'm looking at the dimension of this index, it says that we have 120 rows and 12 columns, indicating that it could be a 10-year data. And more looking at the structure of this index, it is telling me that all these are numbers, numeric, but this one, it has to be a date, but it is looking like a factor, right? Actually, it has to be a date. So that's the reason what we typically do is we'll convert the date, the factor into a date, and again replace it at the same location itself. So that's the reason I'll say index dollar month. First I am doing conversion of a factor into a character. So it is like index dot as dot character index dollar month. So I'm converting it into a character first, and once I have converted it into a character, then I can convert it into a date using the as dot date function. But when I'm using as dot date on a character, I have to specify the format in which it has to read the date. So I could see that the first one is the date hyphen month, the slash month slash year. So percentage D is indicating the date. After that, read the slash, then put a percentage M indicating the month, put a slash, and percentage capital Y indicating a 4-digit date rather than a 2-digit date. So this is how I have converted the factor date first into a character date and again into a real date format, and rewritten in the existing location itself. So now when I am looking at the structure of the index, I see that the month is in a date format. But I should convert this into a time series format so that I can use all kinds of time related calculations on the top of this data. So if I have to convert it, it's better that I load the packages which are associated with time series. Right, I'm loading a package time series so that I can convert this into a time series. So what is that I want to do now? Index, I'm converting it to a time series and again reallocating it to the variable name index itself. So the way I'm converting it is I'm using a time series function. Time series function requires two inputs. I'm not going into the help for all these because these are routine functions and I expect you to be comfortable with these functions by now. So the first input I have to give is all the data which is following a time series. I should not give date as a part of the first input. So which means out of this index I should not give the first column, I'll give all the remaining columns. So this is where I can take index, all the rows, all the columns except the first column. And I have another parameter called character vector. This is where I have to specify the date. So I am specifying the date as index $month. So this is the format in which I can convert a regular data frame into a time series. The first part will contain all those variables which are a part of a time series, which are numeric and which keep changing with time. Whereas the second talks about a character vector which is an indication of the date. So that's the reason I have given this. So which means from now onwards, if I check for the class of index, it would be a time series class. And if I look out for the structure of index, it will come out as a time series object with this as the input. So you see that the period is starting from 2007 January 1st to 2016 December 1st. And the format is the standard date format percentage %y hyphen percentage %m hyphen percentage %d. So this is the data as of now. Now with this I'm ready to go ahead using I'm now ready go ahead using the various specifications relating to the portfolio. So let's start using the portfolio related specifications. For that I need to load the fPortfolio package. So let me load the fPortfolio package as well. Right, I'm taking the fPortfolio package to start with. So if you see a few important points, it has loaded fbasics also within it, which takes care of various statistical calculations required for the financial data. So some of the other packages which are dependent for fPortfolio, even those are loaded. So basically this package is if you are looking at fbasics package, it's more for marketing, analyzing the markets and calculating the basic statistics. And even for the modeling of the financial assets, f-assets package is being used. All of them are taken together for working with the fPortfolio package. Now comes the first aspect within the fPortfolio, wherein I have to go with a portfolio specification, right? I have to go with portfolio specification. Now this is where I have to look at using portfolio spec. Portfolio spec is a structure that talks about the basic structure of the overall portfolio. If you see here, it specifies the portfolio from the scratch. So initially we have to go ahead in terms of specifying the portfolio from the scratch. Now, portfolio specification. There are multiple slots out here. The first one is relating to the model, right? We have to give some kind of specifications relating to the portfolio model. Then the portfolio itself, there are some kind of parameters that we can give or modify, and optimization. So again, different kinds of parameters which can help us in doing the optimization. So generally what people do is they take the default specification to start with. When I'm saying default specification, they'll simply say spec equal to portfolio spec. That's it, without making any kind of modifications inside it. If I want, I can keep changing all of them one by one. But in some cases, whatever the things I want to take as default, so this means everything that is default, that is taken and given to spec. So whatever is the default specification of the portfolio, that is directly accepted, and that is what is given to the variable called spec. So here, what is the default specification? Let's read through here. The model, in the model, the first, there is a type of the model. By default, it is MV. Now, what does the type talk about? The various types of models that you can build. So MV means it's a Markowitz mean variance portfolio. So you must be comfortable with the Markowitz mean variance theory. So based on when I set the type as MV, it means that I'm working with the Markowitz mean variance portfolio itself. Whereas if I'm setting it as LPM, it's per mean lower partial moment portfolio. So it's again, I'm creating a different kind of portfolio. I'm not going with the Markowitz portfolio. I'm going with LPM, which means mean lower partial moment portfolio. And when I'm going with CVAR, it means that I'm going with conditional value at risk portfolio. Right? So I'm creating three different kinds. The default is the mean variance portfolio of Markowitz itself, but I can very well create mean lower partial movement portfolio, or I can even create the conditional value at risk kind of a portfolio, mean and conditional value at risk kind of a portfolio. So the portfolio is prepared based on the mean and conditional value at risk. See, basically, if the portfolio is optimized based on the mean and the variance, it is called as a Markowitz portfolio. If it is based on mean and lower partial moment, then it is called as LPM portfolio. And if it is based on mean and conditional value at risk, which is the expected shortfall. The other word for conditional value at risk is expected shortfall. So if I am basing my portfolio based on mean and expected shortfall, then I can very well use CVAR. So that's one. So when I'm saying spec equal to portfolio spec, so basically the first thing is I'm accepting the default itself. Here we have seen that the default type is mean variance Markowitz portfolio, but if I have to change it, then I have a few ways of making the change. So let me first accept the defaults itself to start with. Right, I'm taking spec as portfolio spec. Means if you look at the spec, all the defaults are directly taken into consideration. The type is MV. So and probably if I'm looking at the structure of spec, I could see that. So within this, the model, there are 5 different things. The type is MV, which is mean variant. That is what I have talked of right now. The optimization, the default optimization is minimum risk. So I want to minimize the risk of the portfolio. So the default is minimize the risk, especially if the target return is given. I am looking at minimizing the risk, but if the target risk is given, it's better that I set it to maximizing the return. So depending on what I am giving, if the return is given, for that particular return, I want the minimum possible risk. And if the risk is given for that particular return, I want the maximum possible return. So probably here generally also we give the target returns only. I want a target return of some percentage. So that's the reason because we go with the target return itself, the minimum risk, the default one looks more and more okay in this case. Then the third thing that it is giving as a part of the default is the estimator. It is giving as covariance estimator. So based on the covariance, the model is typically built. Whereas, so especially for estimation of the risk, the covariance is being used as a measure. When the default is covariance estimator, so the whole allocation of the portfolio is purely based on the covariance. So it is looking at the means of each of the asset classes or sectors of all the various assets that we have, and it builds the covariance matrix, variance covariance matrix between the various asset classes. But at the same time, we have various other kinds of estimators. There is a Kendall estimator, there is a Spearman estimator, there is an MCD estimator. Kendall and Spearman, they are the non-parametric kind of measures of relationship between the two variables. So there is a way that I can change it to Kendall's estimator or a Spearman estimator or various other robust estimators, probably for understanding the what each of these estimators do. You may have to refer to the theory behind each of these estimators. You may have to get into the mathematics behind each of these estimators. But one way I can simply differentiate from a covariance estimator is they are all more robust kind of estimators. So we can very well try out one or more of these estimators. So which means these specifications also could be changed, and the models can very well be and different kinds of portfolios can very well be created. So all these are the different kinds of estimators in case you are selecting MV, Markowitz as the type of the portfolio. But in case you are going with mean and lower partial movement portfolio, the estimator automatically becomes an LPM estimator only. Whatever you are giving as the other forms of estimators, the default would become an LPM estimator itself. So that's one more important specification. Tail risk. By default, it is a kind of an empty list. But in case if I have some kind of a risk budget related constraints, tail risk related budget constraints, if I have, I can very well add them as a part of this tail risk variable. And there are a couple of parameters also that I can specify, especially for different kinds of situations. I may have to use different kinds of parameters. Let's say if I'm using LPM, right, which is the mean lower partial moment. So lower partial moment is again I'm going with the second order moment. So wherein I'm giving an exponent a equal to 2. But if I'm going with the third or the fourth order moment, the exponents have to be changed accordingly. So which means for the lower partial moment kind of models, exclusively for those models, I need the exponent to be set. Or if I'm going with CVAR kind of portfolio optimization models, I need the alpha value to be set, because the alpha talks about the value at risk for that particular level. So at what confidence level or significance level I need to estimate the value of value at risk, and based on that, at what level the conditional value at risk need to be computed for the portfolio purpose. So there are a few parameters which can help us in terms of making the necessary modifications there. So here, as far as these specifications are concerned, these are the model related specifications. So the most common things that I can change here, the estimator is something that we can keep changing. The type, there are three types which are supported, so I can very well change the types of the portfolio models. The estimators, we have seen there are different kinds of robust estimators, not necessarily the covariance estimator. Then the parameters also, especially when I am working with the CVAR kind of model, it's better that I can change different kinds of alpha values as well. So that's how we have different kinds of specifications, right? We'll set a few different kinds of specifications and we'll start working with them. But let's continue the default first. Once we get a hold of the default, we'll start one by one and create different combinations which can help us in doing the evaluation of different portfolios. Then within the portfolio, weights by default are null. So here I have to look at these three things together always. The weights associated with the portfolio. For if I have 11 sectors, how much of weights I have to give to each of the sectors. That is what has to be highlighted as a part of weights. Target return, by default it's null. Target risk, by default it's null. So these are the three things I have to look at them together. So especially if all three of them are null, that is what is the case right now, right? That's the default setting. All three of them are null. What we typically see is we will get an equal weighted portfolio. The default is if I don't change anything, I will get an equal weighted portfolio, right? And we have to understand these three are always interlinked. The moment I am changing one of them, it will impact the other two. So we have to see that whether I am leaving it as blank. If it is a leaving of blank, the default behavior is the equal weighted portfolio is constructed. But if I am giving weights and not giving the other two, then corresponding to that weights, whatever is the feasible portfolio, that feasible portfolio would be considered and it would be constructed. But if I am giving only the target return, but I am not giving the other two, weights and the target risk, corresponding to that target return, an efficient portfolio will be created. The efficient portfolio is the one that is having the least possible risk. So when I am giving the target return, the kind of portfolio that would be constructed for me is the minimum risk kind of a portfolio. If I am saying an efficient portfolio needs to be constructed, it would become a minimal risk portfolio. But if I am giving target risk and I did not give weights and target return, then for that amount of risk that I am having, it will create a portfolio which is giving me the maximized possible return. So these are some of the things that are by default taken into consideration. So again, for different kinds of models, we can very well modify the numbers as per our requirement. Then the risk-free rate, the default value for the risk-free rate is 0, but in many cases that cannot be the case. So it's better that I change the risk-free rate to my requirement so that the overall calculations of the portfolio are done more effectively. So we are doing the risk-free rate. So depending on the country, we are very well setting the risk-free rate. So the default is 0, but we can very well change the number through the various specifications. Then another important aspect of portfolio that is more flexible is the number of frontier points. See, generally an efficient risk frontier is typically plotted, right? This is a kind of portfolio frontier. if I understand the theory, this is how the portfolio frontier comes up, because this is the graph between the standard deviation or the risk of the portfolio and the expected returns of the portfolio. So the graph comes more like this, and this is what we call as the global minimum variance portfolio. And any of these above this global minimum variance portfolio, this whole portfolio frontier curve is what we are calling as the efficient frontier, which indicates that as the risk is increasing, the expected return of the portfolio also keeps increasing. Now what is coming out is how many such frontier points I have to take for plotting. So the default is 50, but I can very well change the different portfolio frontier points as well, which will tell you for different levels of risk, different kinds of expected returns can be obtained from this particular portfolio. And finally, the status says we also have a status. So right now it's not applicable, but once we run a portfolio, by default, when you have done an initial setting, it is NA, but when you start running the portfolio, you will find that it will be set to 0 in case it is successfully accomplished. Then the next section is about the optimization part. So we see here the type of solver that we can use. So the default is saying solver quadratic programming is the kind of a solver that is being used. But if I don't set to any, that's a simple thing. If I'm not setting it to any, if I'm setting it to null, the best solver available will be auto selected. That's the kind of an advantage that we can get. So if I don't select a particular type of a solver, then it will auto select the best type of solver, and based on that our portfolio allocation will be done. Coming to the various portfolio objectives, there are three major things. We can leave it to default: portfolio objective, portfolio return, and portfolio risk. I can very well keep these things as it is, right? And we also talk about the various parameters, further arguments that you want to pass to the model. You can set the various control settings for the solver. And finally, the tracing talks about whether you would like the tracing of the entire portfolio optimization process, the step-by-step approach to the portfolio optimization process. Initially, by default, it is false, but you can very well set it to true, but that would clutter your entire workspace as such. So any of these things, if you want to get those things, get the current values of the specifications, you can use the corresponding get functions. In the next slide, I'll showcase a big list of get functions that you can use. And if you want to make changes to any of those things, we can do the set function, right? So let's get started. So if you see here, there are different kinds. So the set type, you can set it to either MV, the default is MV, but you can very well set it to LPM, or you can even very well set it to CY. Similarly, set optimize, you can very well set to minimum risk, by which is the default one, or you can very well set it to maximum return. Estimators, I have said there are wide varieties of estimators that you can use. The default is the covariance estimator, but you can very well use the various robust estimators that are there, like your Spearman estimator or Kendall estimator, etc. The tail risk, especially if you have some kind of risk budgets associated with the tail, you can set a specific value for the tail risk. So various parameters you can very well set there. So you can give the different names, like we have alpha. For alpha, there is something that's already default, but if you are using exponent kind for your LPM, then you can very well say spec and exponent and give a value to it. Weights, if you want to set, you can set weights. If you want to give target return, you give a set target return, target risk, risk-free rate, right? And number of frontier points, if you want to change, use this. The status, if you want to set, you can very well set. Solvers, you have so many solvers, but as I have said, if you set it to null, the best possible solver will be picked up and it would be used for the calculation purpose. The objective, right, I can set, now that we have seen that the objectives are three: portfolio objective, portfolio return, portfolio risk. And finally, I can even set the trace to either true or false. So these are some of the settings that I can do, right? We'll do a few of them for working with our current portfolios. We'll create 4 or 5 specifications altogether, right? So now going ahead with retrieving, you could see if I have any kind of constraints, I can get the constraint, especially this is after the portfolio creation, right? So let me just see now, get constraints. If right now if you say get constraints of index, but index, no, spec, this is the initial specification that we have. So it's not, so once you have created a portfolio, then you can get all these things. So you can get the constraints of it, you can get the controls, probably will go get back here. If I want, I can get the covariance of that particular portfolio. So I can get the covariance, risk budgets, I can get the data. We'll use all of them and we'll have some kind of understanding of each of these once we have created one specific portfolio for our data. That explains the things to the fullest. So first let me do some kind of settings to start with, right? So spec. So let me call spec. First let's do some kind of settings to the spec. In that spec, let me the spec, let it be a default one, right? So let me use spec 1, which is again portfolio spec, the default, but to that set, what do you want to change here? Let's change the estimator, right? Let me change the estimator of spec 1 to Kendall estimator. I'll make the one of the estimators as Kendall estimator. So this is one thing I want to change to the spec 1. Then what else do we change for spec 1? Let's give a target return, right? So I can say set target return of spec 1. So remember, this is the data in terms of percentage, and that too we are talking about a monthly data. So I can very well give a target return of 1.5%. So or probably let me take it as 0.015, which is the 1.5% stuff. So I can give a set target return of spec 1 to be this much. And set risk free rate also will set risk free rate of spec 1. Let me set it at 0.005, which is 5%, 0.5% per month, because this is a monthly data. I'm setting all of them in terms of months. So I want to set target return, I have set a risk free rate of return, and I can set number of frontier points, fair enough. Set solver, let me set the solver of this spec 1 as null. So some of the basic things I'm setting out here for the spec 1. So quickly, if I see spec 1, so you could see it's a type mean variance, it's a mean variance estimator, mean variance type itself. The optimizing is still the minimum risk, but the estimator is a Kendall estimator. The portfolio weights are not there, but the target return is set, the risk-free rate is set, the number of frontier points are set, the solver is a blank kind of a solver, right? So that's the typical thing that is there as a part of the spec 1. So let me consider the spec 2 now, again using the portfolio specifications. The default initially I started, but here let me change the type. Set type of spec 2, I will change it to LPM. So that's the spec type I'm changing. So estimator, obviously it will become the LPM estimator itself. So even if I don't choose it, it will automatically become the LPM estimator itself. But just to use it, it becomes LPM estimator. Alright, so that's one change. And because I'm using LPM, I have to give the exponent value, right? So I'll say set params spec 2, and I have to specify the exponent, right? And this value I'm setting it as 2. So exponent is not found. Let me just check what is the way we write the exponent. Sorry, A, not exponent. We have to set the parameter, set params. A is 2 instead of 1. So I am giving the parameter A as 2. So that's one more change I would like to give. And let's say here we are specifying the risk-free rate. Again 0.005, and let me do set target return again as 0.015. So these are some of the things. Oh, sorry, set target return and set risk-free rate of spec 2 and set target return of spec 2. So now this should be fine, or probably I can very well go with a different solver out here. Set solver, let me take it as solve R SOLNP. So I am taking different kinds of solvers for us to have an understanding. Set solver of spec 2. So now if I look at spec 2, this is the category LPM, minimum risk, LPM estimator, A equal to 1 and exponent equal to 2. I should very well change spec 2, let me change A as 2. So now let me see spec 2. Yeah, A is equal to 2, exponent equal to 2. We have a target return, we have a risk-free rate, and probably I can change n frontier points also. Set n frontier points of spec 2. Let me set it to 100 instead of 50. So that's one more thing. So this is how we are bringing, and probably we can do a set, we'll keep it like this. So this is what will become my spec 2. Now spec 3, otherwise we'll keep it with these three specifications. We have spec 1, spec 2, spec 3, and probably I want to use solver short. That's okay. It will choose automatically where there is a null. The model is chosen automatically. Now based on this, I want to go ahead in terms of building my different kinds of portfolios, right? So get functions, we will use all these get functions. Once we have built one kind of a portfolio, we will retrieve all these things associated with that portfolio that we have created, right? Now first let's look at a few different kinds of efficient portfolios. So if I want to create an efficient portfolio, which means it has to lie on the efficient frontier. So as the risk of the portfolio measured in terms of standard deviation is increasing, the expected return of the portfolio also should keep increasing. So that is what we are calling as an efficient portfolio. And that I can very well create using the efficient portfolio as a kind of a function. But if you look at based on the different kinds of objectives, the efficient portfolios could be different. So we can see a tangency portfolio or a maximum ratio portfolio. What does that mean? So this is a tangent. So at different risks, we are talking about different kinds of tangent. So maximum ratio. Ratio is the ratio of the return to risk kind of a ratio. So which is in other way, otherwise called as your Sharpe ratio. So I want to maximize this ratio. That is what I am calling as a tangency portfolio. So I can either go with the max ratio portfolio, that's the name of the function I can use, or I can use tangency portfolio. It returns the portfolio with the highest return to risk ratio on the efficient frontier. So generally we are calling it as the Sharpe ratio in case of Markowitz portfolio, but this could be different from Sharpe ratio when we are using when we are using the other kinds of portfolios. Similarly, the return to risk ratio is calculated from the target return, which is returned by the efficient portfolio, and even the target risk. So both of them are returned by the efficient portfolio that we have computed, and the ratio of both of them is giving me the risk to return ratio. So we can look at even this kind of a portfolio. Then in some cases the definition of efficient portfolio means it could be a minimum variance portfolio or a minimum risk portfolio. I can use either this function or this function from the fPortfolio package. So whichever is having the least possible risk, so this is the one. Or at the same time, if I am giving a specific return, right, let's say I am specifying this as my expected or target return. So corresponding to this is the amount of risk. So it will specify the one that is having the least possible risk for a specific expected target return. So the target risk is returned by the efficient portfolio, where the overall risk is minimized. So I can very well create a minimum variance kind of a portfolio as well. Similarly, when I'm giving a specific amount of risk, I can very well create a maximum return portfolio. In this case, in some cases, we have specified the kind of a target risk, target return for us. So I can very well go with a minimum risk or minimum variance kind of a portfolio. But if I'm giving some kind of weights, right, instead of me asking the system to determine the weights, if I'm giving the weights, then I can very well talk about the feasible portfolios. It may not be an efficient portfolio, but with the given set of weights, whatever is the feasible portfolio, that would be typically constructed and it would be assigned to us. So one way I can just simply get started with efficient portfolio, and depending on the kind of inputs, the corresponding portfolios can very well be invoked. So let me look at the structure of how an efficient portfolio is going to look like as a part of the function. So as I said, these are all the different kinds of efficient portfolios, right? Either we are talking about efficient portfolio as a function, or max ratio or tangency, wherein the risk to return to risk ratio is typically maximized. Then we are talking about minimum risk portfolio, where we have for a particular given amount of return, we are talking about a portfolio which is having the least possible risk. And max return portfolio is given a specific amount of risk, I'm looking at a portfolio which can give the maximum return. So within this, there are a few constraints: a character string vector containing the constraints of the firm. So minimum weight of each of the asset, I can give it in terms of some percentage. So which is per box constraints. And I can also talk about maximum sum of weightage of all the assets should be equal to 100% per sector related constraint. So for each of the assets, I can either give this or this, right? Some kind of constraint, and the typical constraint is long only or even short positions are possible. And the data that I have to give is a multivariate time series, right? It should be of a class time series. We have seen that index is already a time series. So otherwise I should have a kind of a mechanism to convert it into a time series. So right now it's a time series, so I can very well go ahead with it. And I have spec. We have three different kinds of specs. So let's go with those specs as such. So that is what we really need to go with, right, in terms of all these constraints. So let's go ahead and create an efficient portfolio. So I'll call it as A1 as an efficient portfolio, right? Let me use this function as it is. So if I'm talking about the constraints, right, let's look at all of them. The data for me is index. Those are the stock prices. Spec, I'll not take portfolio spec. I'll take it as only spec. Of course, here spec is the default settings itself. Constraints, I'm calling it as long only. Then I have A2. I'll create different kinds of things out here. I'll again take, right here, instead of long only, I will add the short as well. So it's not just long only, I can even include the short as a constraint. So these are both with the spec. Same thing I can do with the spec 1. So let me call this A3 and let me put this as spec 1. And let me remove the constraint altogether, saying that there are no constraints. No, but I have to give a constraint. So let me give the constraint as well. Get solver spec 1 get solver of spec 1 is not a function. So I have to give spec 1 solver is not specified. So let me do one thing. Set solver spec 1. Let me take it as short. What is the solver function? Instead of setting it as null, let me consider the solve r short exact. Right? Let me take that. Solve r short exact. So let me take this as the solver specification for spec 1. So based on that, let me see if I can go ahead with A3. Yes. And similarly in A4, I'll just take the constraint to be short. Okay, let this be A3. Then long only, let me make it A4. Or, yeah, long only, let me make it A4. So this is what we have with respect to the second spec. Similarly, I'll take spec 2, right? And I'll call this as A5 efficient portfolio. Now here, so I have to give the model out here. So which is not coming out as a part of long only for this LPM solver, but even in the short, I need to give tau as another parameter when I'm going with LPM. So in spec 2, set params, right? Set params of spec 2 comma tau. I will set it as 0.5. So now let me see if I can go with A5 is not a function, character or symbol. Spec 2 tau is coming out to be 0.5 for spec 2. Okay, let me come back to the spec 2, but at least spec 1 and spec. So let me go ahead in terms of seeing what is there as a part of A1. So now in this A1, the efficient portfolio, it's a mean variance efficient portfolio where I have used the estimator as covariance estimator. By default, the solver quadratic programming solver is typically used. The optimization is a minimum risk optimization and the constraint I have is a long only constraint. Now based on this model, the suggestion that has come out is I should invest around 0.6443 in 64.43% I have to invest in the telecom sector, 4.77 in the FMCG sector, and 30.8 in the energy sector. So that is what should be my portfolio, going with this covariance estimator and a mean variance efficient portfolio. The covariance risk budget wise, again the same logic is coming up. 64% of the overall risk is contributed towards the telecom sector, 4.7 by FMCG and 30 by the energy. Now measuring the target return. So the mean target return is coming out to 1892. on a monthly basis, and the covariance is coming out to be this much, and the credit sorry the value at risk is coming out to minus 14.61, and conditional value at risk at that 95% confidence level is working out to minus 1402. So there is a loss of to the extent of minus 1461. That's the kind of a VAR for this portfolio. But on the other side, what I can very well think of is, instead of taking the index value, I better take the index return, right? If I'm talking about the index returns, I can simply take the returns of the index. And if I quickly want to look at head of index returns, I see that these are the returns that are coming out. Now, when I go ahead with my A1, now what I want to do with my A1 is, the A1 I want to make a modification wherein I want to bring in the index returns rather than the index. Right, instead of index, now I am bringing in index returns as a part of my A1. Now let me see what is there as a part of A1. Now the logic is completely different. Again, this though the model is exactly the same, but the kind of input that we have given, here it is coming out that I have to invest only 0.7% in the telecom sector, right? 0.77% in the telecom sector, around 16.05 in the IT, 18.24 in the healthcare, 62.24 in FMCG, and 2.71 in the energy. And the risk budgeting is also happening with this kind of a proportion. And overall, you could see that the mean return is around 1.05%. The covariance is working out to 4.66%. And the VAR is working out to 0.07. So which is 7.09% is the VAR. And if we are talking about the losses that are beyond the VAR, and I take the average of those losses, which is nothing but the expected shortfall, it is around 11.48%. So these are the different calculations that are getting worked out based on the returns that I have considered for this period as with respect to A1. Then if I look at now, let's say out of this A1, I want to expect so many things. Get constraints of A1. Let me quickly look at all the things. Right, if I'm talking about get constraints of A1, it's a long only is the constraint that is there, right? Then get control of A1, we are getting a controls which is a kind of a list, which is an empty list. There are no specific controls that we have given. But if I say get covariance of A1, important one, we are getting a variance covariance matrix altogether. That's an important thing for us to consider for various aspects. We can look at the covariance matrix. We can say get covariance risk budgets, which is what is these things out here. Get data. Now this is another important function where you are able to get the full data out here. You see here head and tail series of the data. Statistics of the data is there. Mean for each of the industries. So some industries have a negative mean returns, right? So these are the means across. Then covariance, variance, covariance matrix wise, these are the variances across the entire industry altogether. The sectors and the inter covariance between the pairs of sectors. The estimator that we have used is the covariance estimator. Right, based on this, the mu is being computed purely as whatever you are getting as mean out here, because we are using a covariance estimator. The sigma is coming out to be these things. So basically we are able to get the data and a few calculations on the top of it. Estimator is just coming out with what is the estimator we have used, which we already know. The covariance estimator is the one that we have used. So get mean, from here we are going to get that. Get covariance we have already got. Get mu, we are going to get this one. Get n assets, the total assets. Get n assets of A1, giving me that there are 11 assets in the portfolio. So get n frontier points, you are going to get 50. Get n frontier points A1, I'm going to get 50 out here. Get optimum, so we are get optim of A1, we are getting so it is doing a solver, which is solver quadratic programming. These are the objectives, these are the various parameters that we have, and the tracing is typically false. So all the things, if you just look at, you are able to retrieve almost all the things. Get weights is a very important one, which we have already got there. But if I really want to extract it separately, I can simply say get weights, which is going to give me how much I am investing in each of the sectors. So that's what is the output that is typically coming out, right? And if I want the trace, get trace of A1, it is because we have set it as false, I'm going to get it as false. Get statistics. Okay, statistics is nothing but, here you see the mean, the covariance, they are all under the single heading of get statistics. So once your portfolio is created, all these things can very well be retrieved, right? So now, so we have your A1 as a portfolio. Now, if I say A2, right, on A1 I cannot do any kind of plots explicitly. If I'm just saying plot A1, whatever the portfolio I'm able to create, these are the various things that I can create directly on this A1. The plotting is done with an interactive kind of stuff, right? I can plot the efficient frontier. When I say 1, make a plot selection, plot A1, but we should be able to plot A1, but A1 if I am typing, okay, let me just check why it is not coming. So these are the weights, so the A1 should actually get plotted, fair enough, let's go back to it. Then similarly, let me go with A2. A2 again, I'm going with efficient portfolio, wherein I am taking index returns as the data. Then I have specified spec itself, but constraints I have set it as short, right? This is what I'm calling as A2. Now looking at A2 also, as long as my solver programming is quadratic, I'm seeing that the weights that I'm getting is more or less the same. All the other things that I am getting are exactly the same, whether I am giving this constraint or not giving the constraint. Similarly, when I take out the constraint altogether and again go with it, overall it is taking the constraint here, it has omitted the constraint, right? Let me just take the constraint as short. If I look at A2, yes, it is a constraint which is short, but based on that constraint short, it has not done any kind of allocation, right? And if I'm not specifying any constraint, by default it is coming out to be long only. But when we look at the solver to be short exact, that is what I have initially used as A3, where I'll use the spec 1. Let me see efficient portfolio, where I'm looking at index returns and spec 1, and let me say I don't set any kind of constraints. Now when I go with A3, now this is where I'm going to get the shorting as well. So when I use the solver as short exact, and where I have used the Kendall estimator, in those cases I can very well get that the contribution to the reality sector is short 30%, right? You can short 30% of the total portfolio in the reality sector, and you can very well invest 6% in the telecom, 2% in PSU, 8% in oil and gas, 24% in IT, and so on. Overall return is coming out to be 1.5%, right? The mu is 1.5, the covariance is around 4.28. The value at risk, when the shorting is allowed, I could see that the value at risk is 5.61%, right? And I could see that the conditional value at risk, which is the expected shortfall, has come out to 8.74%. Similarly, now let's do one more thing. Spec 2, let me simply set it as portfolio spec, right? But set solver spec 2, only one thing that I'm changing perspective. Set solver, I'll set it as solver short exact. So that's the solver that I set. And I'll set risk free return, I'll set it as 0.005, and let me set target return, let me set it as 1.5%, which is 0.015. And based on that, let me create a A4 where I'm going with efficient portfolio, right? A4, I'm giving spec 2 as the requirement out here. And now if I see A4, here it says based on this model you have to short so many sectors. So the reality you short 27%, oil and gas short 26%, finance short 42%, auto short 15%, and you go long on 6% in telecom, 25%, 21% in PSU, 20% in IT, 18 in healthcare, 51 in FMCG, and 43 in energy, with 48 in bank. Overall, if you see, the target mean return came out to 1.32%, which is higher. So here we got 1.5%, whereas here it is around 1.32%. The covariance or the variance of the portfolio is 4.28%, whereas here it has come down drastically to 3.91. Our objective is to minimize the risk, right? So it is trying to minimize the risk. It has got the 3.91% as the risk through this process. VAR is only 5.11%, and the conditional VAR came out to 7.93%. So these are the different kinds of efficient portfolios. Depending on what input you have given, one of these things come under the set of efficient portfolio. So you can directly use the function efficient portfolio, but if I am trying to plot it, I don't know why it is not getting plotted. Error in row names, values 1 comma 0, length of different dim names not equal to the array extent. Something is going wrong there. right? So I just need to see why this plot is not coming up, but generally we'll get this plot quite comfortably. It's a kind of an interactive graph where you can go right from 1 to 8 as the different inputs to the chart, right? Now, based on the definition of efficiency, whether it is efficient risk to return to risk kind of a ratio, or given a specific target return, looking out for the portfolio that's having the least possible risk, or given a particular amount of risk, looking at a portfolio that is giving me the maximum possible return. So all these things can very well be created through these efficient portfolio function. Now, once your portfolio is created, as we have seen, we can look at the value at risk for a particular portfolio. So it is basically based on the alpha percentile of the last distribution. So when I'm looking at a particular portfolio and I'm setting, let's say, alpha as 95%, what it means is I'm choosing a smallest value in such a way the probability of losses greater than or equal to that value is equal to alpha. So the chance that when I'm saying alpha is 5%, the probability that the losses are greater than or equal to that particular number is 5%. Right? So that is something that I can very well compute as a part of the portfolio VAR. Now if I look at pfolio VAR as a computation, pfolio VAR, or I think I have to give A as a small letter. So it computes the value at risk and the related measures for a portfolio of assets. So these are all the various computations that I can do. So that is what I think I have listed out here. So we'll talk about them. Portfolio VAR. All I have to give is I have to give the X, which is the model that we have got. No, X is a time series object. So we are giving the returns and weights and alpha. So these are the three things if I give for my model, I will get the var of each of the portfolio. So let's try this out. So instead of X, I'll call it as index returns, right? This is what I'm calling as X. Instead of weights, I'll use the get weights function. So get weights, I'll get it from the A1. I'll get for all the models. So based on that, I'm computing the portfolio var for the first model that we have created, first specification. So that says it's around 8.52% for an alpha of 0.05. So we get the portfolio var of or 8.52%. Similarly, if I set this to 1%, then the number is much higher, which is 18.95%. Right? Going with A1. Then the same thing, if I'm going with the A2 model that we have created, so in that case the var is coming out to be 0. I don't know why this A2 did not return, but let's take A3. So A3 is a model giving me that the var is around 13.33%, going with the A3 at 1% level of significance. And going with the A4 model, you can revise what all we have kept as a part of A1, A3, A4. My A4 model has given that the 1% var is around 12.24%. So I could see that in the third case, which is A4, the portfolio var is the least. And if I am quickly looking at what is this A4, I'm doing a covariance estimation where shorting is very much allowed, and this is the way we have invested in each of the securities, which has resulted in this as the mean, this as the covariance. So the var, this is a 95% var, but we have computed a 99% or 1% significance level var, which worked out to 12.24%. So that's how the portfolio VAR has come out. Then the next calculation that we are bringing in is the portfolio value at risk, which is the portfolio CVAR plus, which is nothing but I'm computing conditional VAR plus, means I'm looking at the mean of those losses which are greater than or equal to the VAR. So that's the reason we are calling it as, so we are looking at the losses, their expected value, which is the mean, the losses which are exceeding the VAR. That's the reason they have different kinds of names. In some cases we call them as expected shortfall, ES, or mean excess loss, the losses which are exceeding the VAR. So that is what we can very well get through portfolio CVAR plus. So again, if you see, the function is more or less the same, right? I can very well take that function as the input. Portfolio CVAR plus, if I'm looking at it, I'm talking about index returns as the input. The weights I can very well get weights of A1. Alpha I can very well set it as 1% or 5%. So based on my A1 model, the CVAR plus is coming out to 18.95%, where we are talking about the average of those losses that are exceeding the VAR. It's only one value looks like that has exceeded the VAR here. The same way, probably with all the models I may encounter the same, because the data size is much smaller. Here also it's working out to 113.33% going with the third one, and going with the fourth A4 it's coming out to 12. But if I do a 0.5, I'll get a different 0.05, I'll get a different return, because there are a few values that are exceeding the VAR there, and I'm taking the average of all those values, which will give me the expected shortfall in that particular case. So those are the another set of numbers that we compute for the portfolio. And then if you look at the rest, we also have compute the conditional VAR, right? For a portfolio of assets, we have computed the conditional VAR, fair enough. Then portfolio maximum loss, right? Conditional VAR for a portfolio of assets, wherein it will also give us the lambda value, which is like a weighted average between VAR and the expected loss, both of them taken together. So it will lie somewhere in the middle itself. So when we are talking about the same portfolio CVAR, instead of plus, if I simply take portfolio CVAR, then it is the kind of a value that is in between the two. So there is a kind of a lambda that is taken as there is a lambda that is taken as a weight factor. So it would typically be worked out like this. So there is this is computed as lambda times VAR. So 16% weightage has gone to VAR, and the remaining 84% weightage has gone to CVAR plus, and that is what we are calling as the conditional value at risk for this particular portfolio of assets, which is what is typically coming out as 9.26% in this case. So CVAR, so the weightage, this is how the weights are given. CVAR is convex, because you may see depending on the lambdas, it may go down, and after a particular value of lambda, again the overall CVAR can keep increasing. But in case of VAR and CVAR plus, they are all non-convex. And the typical relationship that you see is VAR, CVAR, conditional value at risk, lies between the value at risk and CVAR plus, which is the expected shortfall. Similarly, if I want the worst case scenario, I can go with the fPortfolio maximum loss. Right, so in this case, I can very well say fPortfolio max loss, which will give me the maximum loss of the portfolio. So I need to get unused argument, so I don't need to give alpha now because it's more of maximum loss, so I don't need to give alpha out here. So this says that the maximum loss that is coming out in this scenario is minus 12.24%. So that's the maximum loss that you can create on this portfolio. And if I'm talking about the fPortfolio return, which is the portfolio returns per each of them, I can very well get the return. Across, I can get the returns of the portfolio. So in case of weights, I'll say get weights of let's say A4, and if I say index returns for each of the days, it will compute the returns for me. For each of the entries, it will compute the portfolio return. So I can very well make out on each of the days how the portfolio return is typically like. And I can also compute the portfolio's target return through this, which is the kind of a mean return that I am getting. So I can very well go with get weights of A4, and I can very well get the portfolio's target return as well. So the fPortfolio target return. So here we have already given the target return, right? In this case, we have already given the target return. So as we have given the target returns, we don't need the weights and all these things. No, this is very much applicable only if it is a feasible portfolio, because this is a kind of an optimal portfolio that we have computed. I can very well get my target return directly. I think the same thing will go with portfolio target risk as well, but we did not specify the risk out here. Yeah, in this case we did not specify the risk, we have only specified the return. So the risk is computed, which works out to around 3.91% is the standard deviation of the portfolio. And I can also get the histogram for the portfolio typically plotted, right? So I can very well specify this aspect where I can get the portfolio histogram. The weights I can very well give from get weights of A4. So these are the weights that are getting assigned, and X is talking about index returns. So based on that, so here also I should not give the weights. Okay, I don't know where the problem is coming out, but yeah, probably you can use all or majority of these functions. You can basically compute the value at risk and various other related measures associated with the portfolio. That's one more thing that you can do. Then coming to the efficient frontier. So if I use this function portfolio frontier, so you could see it's computing the efficient portfolio frontier. So let me look at how I can give this efficient portfolio frontier. Let me take these as the inputs with different, right? Let me just give it as XYZ as the name of the variable. So I'm creating a portfolio frontier. The data for me is index returns. The spec I will take it as spec itself instead of spec 1 and spec 2. We can do the same with spec 1, spec 2 as well. Constraint, I can give all these things, I can keep them as it is as well. So based on that, I have got a portfolio frontier created. So when I am saying XYZ, this is how my portfolio frontier got created. So different weights, right? If I'm investing 4.7% in telecom and 95% in reality, that's one combination. Similarly, 5.56 and 40, another combination. 51, 9, 3, 35, this is another combination. So like that, I am talking about different kinds of combinations which are giving different layers of risk altogether. So if you look at overall stuff, these are the different layers of returns that are coming out, and these are the different standard deviations or the covariances that are typically coming out. And this is how the VAR, CVAR and VAR have been changing for this particular portfolio. So if I am looking at the structure of XYZ, so this is how the whole thing is coming out in the structure. So if I really am interested in the whole set of values, the mean and the covariance associated with all the 50, right? That is what I might be interested in plotting. In all the cases, so this is what has worked out to the target risk overall. Here I should be getting the list of all those 50 means and variances as such. Let me just type it once again, XYZ. So this is what is the value that I am getting. So it has specified 5 out of the total 49 points that it has created in the process. So where are those 49 points? I'm just trying to trace those 49. What are the numbers that came out? Minus 0.014.0075. Minus point So this is what has come for only 5 of them taken at a time. Number of assets is 11. So overall it is not displaying for all of them. But let me see if I am able to get the plot of this as such, if it is possible. Yeah, now let me see if I can get the plot from here. Yes. Alright, so now this is possible. So I am going with an efficient frontier for this, which is working out to be something like this. As the risk is increasing, the target return looks more and more decreasing here. But only above this, I am seeing that the returns are typically going up. And if I have to look at the minimum risk portfolio to this, if I want to add the minimum risk portfolio, so it is typically added. The red one indicates the minimum risk portfolio out here. So this is the minimum risk portfolio altogether. We have got that. If I have to add the tangency portfolio, this is what at this minimum risk is what we are seeing. The tangency portfolio getting operated. Then I can put the risk and return of the single assets for each of the asset combinations. I can take the risk and returns which are coming plotted in this way. Right, different securities risks and returns are typically getting plotted. And if I want an equal weighted portfolio, I can type a 5, which is giving me that this is the return associated with an equal weighted portfolio. Then if I want to add two asset frontiers with this, so these are the two asset related frontiers, means if I am taking only two assets at a time, this is how the various frontiers are typically coming up. And even I can add the Monte Carlo portfolios, means I am simulating these portfolios and this is what is finally coming out. And finally, when I am going with adding a Sharpe ratio, this is what is getting worked out as the Sharpe ratio for the portfolio. So these are all the kinds of interactive graphs that I can very well generate, and if I am pressing 0, I am exiting from this overall process as such. So that's how I can very well create portfolio frontiers. Right now I can try out let's say the portfolio frontier with another set of specifications altogether. Right, a simple, let's say I'm taking spec 1 or spec 2, right, with the index returns, and I'm trying to see what is the portfolio frontier that has come out. So now here it is saying I have gone with Kendall estimator, the minimum risk, right? These are the 50 different points that have come. Based on that, these are the points that are selected, and based on this, these are the different returns and the risks that are associated in each of the cases. So I can now very well have a plot of this as well, right? I can very well go with a plotting of this, which is again the same story. I can very well give all the numbers. So this is where the efficient frontier is coming out. This is the minimum risk frontier. The tangency portfolio is added at that particular point. Though each of the individual assets, when I am looking at the risks associated with each of the individual assets, that is where it is working. Then equal weighted portfolio is going to give me that kind of a return. So you can very well do all these kinds of things once you have a model that is typically created. Similarly, I want with respect to spec 2 again another set. So the portfolio frontiers are typically created based on these various stuff. You could see these are the mean returns. This is the covariance. So you can get the graphs of these kind of things plotted as well. So this is how we are creating different kinds of portfolio frontiers, where we could see the efficient frontier of the portfolio as well. So this is one kind of calculation that we are interested in. And finally, we are also looking at risk budgeting, right? How do you allocate the risk across the various sectors or across the various asset classes? So for doing that, we have first a few calculations that we are doing, which again we have done earlier as well, where the VAR and the expected shortfall, etc. of the portfolio are computed. Or I can also compute the sample covariance, and the budgeting can very well be done based on either sample covariance or the normal assumption of VAR or a non-normal assumption of VAR, which is coming out as a modified VAR, or a normal assumption of expected shortfall or a modified assumption of expected shortfall. So if I simply look at those set of functions, right, I can very well say I want sample COV, right? I say I want sample COV. So this you can see all these kind of things that you can calculate. So let's get started. I want to find out the sample covariance of the index returns, which is direct, which has nothing to do with the weights or anything. So I am getting the covariance of the index returns, but I want the VAR based on the normal distribution assumption. So based on the normal distribution assumption, if I really want the VAR of index returns, so these are the VARs of each of the individual securities. This is not for the portfolio. So based on this, you could clearly see a 95% VAR. Reality sector is having a very big risk, right? PSU is less risky, oil and gas is less risky, IT is even lesser risky. FMCG and health look like the least risky out of all of them, whereas the reality sector looks more and more risky as per the normal VAR. So under the non-normal kind of a VAR, which is what we are calling as a modified VAR, which is an adjusted kind of a VAR, which does not assume the normal distribution return. So even here I could see more or less a similar kind of a situation. Reality is looking more and more risky compared to various other sectors, and FMCG looks the least risky of all of them, right? And I can very well do the budgeting based on the sample covariance. I can do the allocation of the overall risk of the portfolio to the various sectors. So based on the weights, if I'm saying get weights of A4 or A3 or A4, let's say I'm doing A4, and I want to allocate the overall risk of the portfolio to the individual asset classes or to the individual sectors based on the weights in which the allocation is being done. So I am using the sample covariance per allocation, where I could see here the overall risk of the portfolio is around this much, right? 3.91%. Looking at the contributions, around 0.25% is allocated to telecom, then again minus 1.05 to reality, and so on. This is how the allocation has been done. So the overall contribution wise, each of the sectors to the overall, if I am typically looking at the contribution of each of the sectors to the overall risk, these are the weights in which the overall allocation of the budgets to each of the sectors has been typically taken care of. The same way I can go with a budgeting based on the normal understanding of VAR, the modified VAR where a non-normal thing is taken care of, or I can go with expected shortfall again under the normal distribution assumption versus a non-normal distribution assumption. So based on all these things, again we can very well calculate the various aspects of risk and allocations to allocation of the risk to each of the sectors constituting the portfolio. So this is what I wanted to cover as a part of this session. I hope you got a good amount of understanding of creating different kinds of portfolios, doing the allocations, monitoring the portfolios, doing some kind of risk related calculations on the portfolios. So take a different kinds of portfolio. You can practice all these various calculations, and even you can use this knowledge for the practical implementation for your trading and investment purposes as well. So if you have any further queries, you can very well get back to me by giving me a call on the number that I have given below, or you can even send in an email at the email address that I have provided below. Thanks a lot for listening to this session. Thank you very much.